Hello everyone. In the first part of this video, I started making a 2D platformer by modifying some source code I had found on the internet. I changed the source code's window size and resolution to make it compatible with some Castlevania backgrounds I had found. And I made my own animation engine to create a fully animated character, in this case Mega Man. The next step is making my character attack, which I'll be covering in this video. In order for Mega Man to fire his Buster Rifle, I need to make a moving sprite appear on the screen when Mega Man attacks. Fortunately, there already is an example of a moving sprite in this game. The player object is a moving sprite, so by examining the player object and learning how it works, I can find out what I need to do to create a similar object to use as a projectile. The player sprite has a few key variables that allow it to work. The first of these are its x and y coordinates. As you might expect, these coordinates describe the sprite's position. The x value represents the sprite's position on the x-axis, which is the axis on which the player can move left and right. The y value represents the sprite's position on the y-axis, which is the axis on which the player can move up and down. Since the upper left corner of the level is 0, 0, moving the player to the right increases its x value, and moving the player to the left decreases the x value. That might sound obvious, but it's important to note that the x and y coordinates refer to the sprite's position on the map, not the position of the sprite on the screen. If you move far enough to the right, you'll notice the background moves, but the character stays in place. This is because the camera draws the background based on the player's position on the map. It doesn't change any of the sprite's coordinates when it draws them, so no matter where the first block of the level is being drawn by the camera, it always has a position of 0, 0. Apart from its x and y coordinates, the player object also has x and y velocity variables. If you're familiar with the word velocity, then you might know it refers to how fast something is moving. In this case, the x velocity represents how fast the character moves left and right, and the y velocity is how fast it moves up and down. When the game updates, which is continuously, the x velocity is added to the x coordinate. If the x velocity is 0, 0 is added to the x coordinate and the sprite doesn't go anywhere. If the x velocity is 10, however, the sprite will move 10 pixels to the right. If the x velocity is negative 10, it will be added to the x coordinate and the sprite will move 10 pixels to the left. When the player is standing still, it has an x velocity of 0. If I press the right arrow key, it will change the x velocity of the character to 8, meaning the character will move 8 pixels to the right on every update until the key is released. When the key is released, the x velocity is returned to 0 and the character stops moving. If I change the x velocity of the character to 18, the character will move 18 pixels on every update and appear to be moving much faster. The x and y velocity variables simply describe how fast the object moves by assigning how many pixels its coordinates should be moved in any particular direction. That's all there is to know about the player object apart from how it detects collisions. Since the projectile doesn't even exist yet, it can't really collide with anything, so there isn't any reason to worry about that right now. I can take what I learned about the player sprite's x and y coordinates and velocities to create a moving sprite on screen. After looking at the player object and learning how it works, creating a moving sprite on the screen is pretty easy to do. All I need to do is create a new sprite object, set its x velocity variable, and decide its starting coordinates. Then I can add the object to the screen by adding it into a sprite group that the game already draws on every update. If I create a sprite object with an x velocity of 3 and the same starting position as the player, then add it to the background sprite group, the result will be this. A block will move slowly across the screen, moving 3 pixels to the right on every update. This works pretty well just to test the idea to make sure it works, although there is one problem to fix. Adding the projectile sprite to the background sprite group will cause animation problems. A sprite group is a container filled with sprite objects. When the game draws an entire container, it will draw every sprite inside the container, but it won't draw them in any particular order. So even if the projectile is added last, it might still end up being drawn behind the background where it can't be seen. To make sure there aren't any problems with which sprite should be drawn first within a container, all I need to do is create a new container, then have it be the last container drawn. This way, when the game draws the sprites to the screen, it will do it in layers. First the background sprites will be drawn, then the player, and then the projectiles. Now that I have a moving sprite, I'd like to add more sprites by pressing the spacebar. Eventually this moving block will be a projectile, so I need to add more moving sprites when Mega Man attacks. In this example, pressing the spacebar will add more moving blocks from the player's starting position. What I need to do next is add blocks from the player's current position. In this example, I can add blocks based on the player's Y position. And in this example, I can add blocks from both the player's X and Y position. Now it looks a little more like Mega Man is firing a projectile, except that most projectiles don't look like a giant block of bricks slowly floating across the screen, so I need to pick out a better sprite to use. In this example, the sprite looks better, but clearly has some size and transparency issues. After fixing it up a little bit, it looks pretty good. If I adjust its starting position and increase its velocity, it looks like a real projectile that I could use in a game. Although at this point I can only fire to the right, so I have to add the code for firing to the left. Originally I updated the projectile by updating the entire container, but changing the X velocity from 16 to -3 on the entire container when Mega Man turns left or right doesn't work out so well. Instead of setting the velocity of the container, I needed to set the velocity when the sprite object is created, to make sure each sprite in the container has its own velocity. This way, Mega Man can fire left and right and it looks pretty good. At this point, it might look like projectiles just fly off the screen and the mission is accomplished. Mega Man can fire projectiles and there's no problem. Although I noticed that if you wait around a few minutes, the projectiles off camera eventually run out of screen and end up back in the frame. To make sure the projectiles don't come back, they need to be destroyed at some point. Hitting a wall would be a good place to stop a projectile, so I had to make the projectiles capable of colliding with the platforms. I copied the collision code from the player object, and it does detect collisions quite well. The only problem is it doesn't detect the collisions in the right place. This is the same problem I had with my player object being a different size than the graphic that was drawn on it. My solution to that problem was to create another object to draw over the player object that would follow it around. This solution worked, but I had a better solution this time around. To fix the collision problem with my projectile object, I added a sprite object to my projectile object that was just for detecting collisions. This built-in sprite object could be modified as needed to place its detectable area wherever it needed to be. It works just the same as my previous solution, except without having to create an entirely new object. With the collision problem fixed, Mega Man can now fire his Buster Rifle and all the fun of playing as Mega Man can be had, jumping and shooting. Now all I need to do is add enemies so he has something to shoot at. But I'll take on that challenge in another video. I hope you enjoyed watching this project develop, and I hope you will tune in for the next video.